My bound duty to welcome the today's speaker, Dr. Surendran, Principal Scientist and Head, Land and Water Management Research Group, Kerala. Dr. Surendran, I am very happy to see Dr. Surendran in our department, Center for in our department, Environmental Science, and the way back from the year 2001, and we both attended classes in this lecture hall as a PhD scholar. He is a PhD scholar of soil science. We all attended the common course, environmental science. Dr. Surendran, right from his schooling, and he is very shrewd and very studious student. And he used to, when Surendran attending the classes in environment science, we used to study a lot. Being environment science student, we should not give first mark to the soil science students, right? So we do study a lot and try to score high marks than Surendran. Sometimes we'll make it, and most of the time we may not make it. That is the story. At this juncture, I welcome Dr. Surendran. About Dr. Surendran's profile, Sir has completed 23 research projects. Among the 23 research projects, 12 crores money he has brought to the center, and he has completed more than 80 published more than 80 research papers, and he has received 12 meritorious award national-wide. He is one of the well-known international scientists. Quite often he visits a lot of country, and in fact he is a very busy person. Honestly speaking, when I called him many times for conducting the Vaibhavosi or fixing a date for Kirtana's public defense, really not able to reach him because his schedule is very tight. You know about Kerala, most of the time they'll be having a lot of issues, and being a head of the department, he has to settle all those issues. Despite his tight schedule, he has come out with 23 research projects and 80 publications. Is real achievements. And on behalf of Department of Environment Science and Tamil Nadu Agricultural University School of Postgraduate Studies, I welcome Dr. Surendran for the invited guest lecture.
Thank you, Prashant, for the nice words. As Prashant mentioned, actually, it's my pleasure to be here almost after 20 years, you can say. And whatever today I am there, it is all because of TNAU. So with that brief note, I'll go into the topic, and I don't want to take you long time sitting here, even though I have come with a lot of slides, but I'll try to skip it in a faster way. So the topic what I thought was discussing is about the use of or application of decision support systems for effectively managing water and nutrient management, especially for improving the crop productivity, and that too under the changing climatic scenario. So these are all the topics which I thought we'll be discussing today, mainly about the scenario, agriculture scenario in India as well as Kerala, because they're what we are working, but some of the projects we are working related to Tamil Nadu, even other states like Madhya Pradesh, Gujarat and all. Then some solutions or what is the strategies of the DSS which we have attempted. These are all the few listed down, and most of these projects are funded by DST, TFAC, Environment and Climate Change, Ministry of Water Resources, Government of Kerala, as well as the State Planning Board. So this is the general nutshell about the scenario, so which I will not, in depth I will not discuss. If you look at the production scenario coming. So if the production scenario, if you look at that, agriculture and horticulture is having what do you call, it's a growth rate is phenomenal, especially when you look at the horticulture crops. And compared to other nations across the globe, we are very fortunate that almost 50% of our area is under irrigated conditions, which is very good for the productivity. And initially our focus was on mainly to increase the production or to feed the population. So the quantity was our focus. But nowadays, recently, it is shifting towards quality also because the standard of living is improving. So if you look at the production, we need to have around 450 million tons by the year to 2050. But currently we are around 290 to 310, or that way if you look at the agriculture production. Horticulture is around 340 million tons. But still, you may have to improve or almost double the food production to feed the entire population. But if you look at the productivity, this slide, you can clearly understand that India is lagging behind, because for many of the crops, our productivity is in the rank of 50s, 40s, like that. So still there is a lot of scope for improvement. So for which only we were attempting different solutions by which how we can improve the productivity. And these are all some of the crops with specific to Kerala. Our production is very less in pepper when you compare with the other nations like Vietnam, Malaysia, Thailand, and all. And the main reasons what we could understand is with respect to Kerala, I'm speaking, but generally it will fall good for the other parts of the India also. Mainly, whatever rainfall we are receiving is especially during the changing climatic scenario, the intensity of rainfall is very high, and which is leading to soil erosion. While eroding, it is taking away the fertile topsoil. So the soil health is affected. In turn, it will affect the water holding capacity of the soils. And if you look at the Kerala soils, almost 60% of the soils falls under lateritic, which have a very low water holding capacity and deficiency of many nutrients, including micronutrients, whereas toxicity of some of the nutrients were found. And again, another peculiar with respect to Kerala is, even though we receive an annual rainfall of more than 3000 mm, per year. But if you look at the water availability during summer, it is very pathetic, like water scarcity will be there and crop water deficit is there. So irrigation is also not a practice as such. And climate change, as all of you know that it is now evident. And with respect to Kerala, you can see from 2018 onwards, consecutively we are facing the floods or drought in alternate years, and that is having a direct impact on the agriculture. As I mentioned, now our focus is shifting more towards quality. And for that, there are several options that are available, some of which we have attempted with the case studies and experimental studies or farmer-based participatory approaches, how to manage the water and nutrient so that the agriculture production can be sustained. So I'll go into some of our case studies. This is one of the funded program by DST under India-Austria program, in which we have attempted with evolving sustainable package for the land, soil, and water nutrient management in collaboration with Institute of Rural Management, Anand, and National Institute of Hydrology, as well as International Institute of Applied System Analysis, Austria. So as I mentioned in the beginning, we have taken three areas for our case studies. One is Kerala, Kozhikode. It's a district level. And next one is in Madhya Pradesh. It is a smaller, panchayat kind of smaller area compared to Kozhikode. Tikkamgarh one, it is a very drought prone region, Bundelkhand region. And the next one is the entire state of Gujarat. So we have compared all these things using different models. Especially here, we have attempted with the global agroecological zonation model. And since the project was funded under Indo-Austria program, it was under the direct supervision of FAO, how to go about with the climate change scenarios and what can be done for implementation of or sustaining the agriculture production. So these are all the parameters we have tested, like means used in the analysis: climate, water, soil, land use, irrigation, and it has 5 modules. So this study has been done during 2013-14, that period up to 2018. So initially that time it is based on the IPCC CIMIC 5 scenarios. So we have taken almost 23 GCMs, out of which these 4 GCM what I have listed down is matching with the Indian climatic scenarios. So these 4 GCMs we have assembled together and brought out a new model which is very similar to the baseline. Baseline here I am meaning is the historical data of 1980 to 2010, and with that we predicted the future scenarios, as I mentioned. But currently, as per IPCC, now it is CIMIP 6 or AR6. So here the only difference is what we are considering the socio-economic pathway, or we call it as SSP 1.9, 2.6, like that. It's a worst scenario is SSP 5, 8.5. So for all the scenarios, we have simulated the crop production. So the crop production is simulated based on the first one is we will understand the crop suitability based on the climatic characteristics, soil characteristics, means edaphic assessment, and then based on the critical parameters, how the climate is influencing, how the soil is influencing, how the water limited condition is influencing, we'll assess the yield gap, and based on that, in the module 5, we will integrate all those things so that what are all the management strategies or management options we can suggest for improving the crop productivity. So these are all some of the strategies we have attempted. And as I mentioned initially, we could understand that this is using the gridded data of IMD we have done, like 110 years data. So we could clearly observe that the rainfall pattern, this is just an example of rainfall. So after 1960s, we could observe a drastic change in the climatic, especially the rainfall pattern, which is mainly due to the different anthropogenic effects, but still the intensity of rainfall is increased a lot. So based on that, we have predicted all the parameters which is necessary for predicting the crop yield. So for example, in this case, we have initially understood what is the attainable yield for the black pepper under different conditions, whether if it is irrigated or rain-fed, like that. Different options, different crops we have attempted, and along with that, the strategies also we have developed for the future scenarios as well as the current scenarios. So if you look at this specific case, when you look at the site suitability, we could understand that especially with respect to Kerala, if you look at that, coffee is more suitable in some packets like Wayanad, Palakkad, specific areas, Attapadi, then Idukki district. So these three districts which is currently suitable, which will not be suitable by 2050. That is what our findings shares, and which was like we were also shocked to know that because the temperature difference or the climatic difference was very little, like 0.5 to 1 degree. So with that 1 degree temperature difference, which will have a definite impact on the crop suitability, we thought we have to assess it furthermore. So with the help of Coffee Board, we have discussed with them and then got the information about the crop suitability. So then we could understand that why that difference is coming, because these two are the commonly grown coffee varieties, Arabica and Robusta. So if you look at the table, you can understand that highly suitable means the mean annual temperature should remain around 20 to 24. Even 1 degree increase here and there, it will go to the moderately suitable or marginally suitable. So such a sensitive crops, few of the crops, this example I am saying coffee, but similar is what the results we observed with the other crops like spices, plantations and all. Whereas we got some positive information with respect to coconut, arecanut and all, which shows that the productivity will improve. So then we have got for a detailed study with the support of Coffee Board, so that we could understand that if you manage it properly, then we may be able to sustain the coffee production as well as the coffee area. Then this is another study funded by DST in which we were looking at the adaptation option for river basin scale. So here we have taken Bharatapuzha river basin, which is very near to Coimbatore, like Palakkad. So it has means sharing with the Tamil Nadu also some of the areas. So detailed analysis with respect to climate, hydrology, as well as the soil related parameters, then crop production related parameters we have done, and then gone for the climatic variability analysis, which shows that rainfall is significantly decreasing, temperature is increasing. But the peculiarity is that if I mention that you can look at this image, particular image, even though within a small basin, we have a lot of variations, and especially in the southern corner of the portion, you can see the difference. So what we have done is, this is not done by usual analysis, means it will be very difficult to quantify that. So we have gone for a new methodology by which the zones has been classified based on the bioclimatic zones, and it has been divided into 4 zones actually. So then the similarity was there, so that we can understand that what is the difference existing between each zones within a smaller area itself. We can understand the difference. So under future scenarios, for example, in SSP, the worst scenario, if you look at the SSP 5, we could understand that most of the areas are becoming drier, so that the possibility of droughts will be much higher in the future scenarios. Then hydrologic modeling was done using SWAT. It is a soil and water assessment tool. So from that, this outputs from the SWAT has been linked to the crop modeling using DSAT. with the help of few field experiments at our institute center, as well as some of the farmers field for calibration and validation of the models. And we have calibrated for specific varieties to Kerala, as well as because some of the study areas were in Tamil Nadu also. So we have taken Tamil Nadu varieties also. So in this particular study also, we have gone for the future scenarios. So here you can see that for different models, as I mentioned, we have taken some 23 GCMs, and out of which some 4 GCMs was matching to the closer to the Indian climatic conditions, as well as the specific to Kerala. So that we have ensembled it and come out with the ensembled model. With that, we have predicted the rice yield for different scenarios, SSPs, and almost the result showed that around 8 to 28% of yield loss has been noticed with respect to rice. As I mentioned, it is not to threaten or something like that. With respect to paddy, coffee, spices and all, which was too much sensitive to these kind of approaches, whereas we got some positive results with respect to coconut, arecanut, which showed improvement in. So the strategies what we have done is to go for effective water and management options, water and nutrient management options. So this what we have attempted is with the support from DST as well as the state planning board. We have gone for demonstrating this particular technologies, water and nutrient management strategies for improving the productivity and to offset the issues with respect to the climate extreme events as well as the rainfall variability. So this one of the study showed that this is the deficit, especially for the Kerala crops, irrigation demand as well as the deficit because of mostly the Kerala, it is rain-fed situation. So almost 18 to 21 weeks will be under moisture stress period. So how to address that? There only we have gone for this drip fertigation technique, which has been already evaluated by us in different conditions. But this what we have approached is which we have gone into the farmers field as a farmer participatory approach funded by DST. So some 22 plots have been established in different parts of the Kerala with water as well as the nutrient recommendations were generated by us. But the field maintenance as well as the monitoring of crop, everything was done by the farmers. So we prepared the fertigation schedule as well as the water requirement. So for that we have used CropWatt, Hydrus as well as nutrient budgeting softwares to come out with the recommendations. So these are all some of the plots, and in most of the fields initially we have monitored the soil moisture, and based on that only the models were calibrated. So for example, this is one of the plot in banana at Thrissur. So you can see that suppose if you are irrigating for 2 hours, how the soil moisture will be distributed in a consequent period, like 2 hours what will happen, 6 hours what will happen, like that. So accordingly we can fix up the next irrigation schedule based on the soil moisture characteristics as well as your crop requirement. So both have been considered. For example, in this case for banana plot, we need to irrigate after 2 days. It means for up to 48 hours it is maintaining that soil moisture. So the next irrigation can be after 48 hours, means 2 days. Whereas for the vegetable plot, it was like every day you have to irrigate. That is how that difference can be found out, and then that schedule has been given to the farmers. And for the convincing the farmers, we have gone with some field measurements at their field itself, so that they will understand, and with the help of leaflets, brochures and all, they have been sensitized. So these are all some of the demonstration plots, open as well as precision farming, under controlled conditions, and some kind of workshop seminars has been carried out. And then based on these output, we have come out with the recommendations, what is the quantity they need to irrigate based on the generalization on the agroecological zones of Kerala. This was a collaborative project with the NBSS LUP. For this is just one sample I am showing. Just like that, for many of the crops, we have come out with the irrigation as well as the nutrient requirement, and it has been accepted by KU, and it is now as the package of practice. It has been disseminated to the farmers. And we have another one technology which we have developed, the low-cost soil moisture sensor based automation. So these are all some of the outputs from those particular project. So here currently the moisture sensors are available in the market. If you go for a drip irrigation companies like Netaform, Jain and all, which cost around 1 lakh or more than that. But other sensors which may be around 1,000 rupees or 2,000 rupees, it's also available in the market, but which may not be sensitive and accurate. But this what we have developed is almost around 8,000 to 10,000 rupees. And with the mobile based application, it can be operated. So automatically based on the soil moisture as well as the crop requirement, the irrigation has been automated. So this was the outcome, like 100% higher yield, most of the plots we got, and almost the shelf life of the produce is also very good. And in general, we got around 30 to 60% of savings in water, but on an average, you can say around 40%. Then electricity means energy saving is also there, and empowerment of farmers were also there. This is one of the work carried out by a postdoctoral fellow with me on modeling the transpiration and soil evaporation of cowpea using dual crop coefficient. This is also based on the FAO based method, how to differentiate the evaporation and the transpiration, means how to partition that so that effective management strategies can be achieved. So these are all some of the results from that particular experiment, and we found that almost irrigation after 45% depletion of available soil water showed lesser water requirements and higher yield than irrigation at 2 days intervals, and drip irrigation produced more yield as well as compared to the as well as water use efficiency compared to the production. And this is one another new technique. If some of you even for the home, like what you call kitchen garden or terrace cultivation, this can be utilized. It is a wick irrigation technique, like this we have applied for patent. It's under process. Water use efficiency is much higher than even drip irrigation, around 30 to 40% over drip irrigation. And it can be tried in the field also, but field wise, if you look at that, cost may be higher because the PVC pipes has to be laid, whereas in the home gardens means even used water bottles can be used. And with respect to nutrient budgeting, we have linked with the earlier results from the different projects. And this was one of the projects funded by Department of Science and Technology, in which we have quantified, because as I mentioned in the beginning, we have a rainfall of around 3,000 mm, out of which almost 70 to 80% falls in 3 months. So the intensity will be very high. So to understand that, we have gone for this quantifying the soil erosion as well as the leaching. We have gone with the multi-slot devices as well as the different techniques we have used, including isotope techniques, and it has been quantified. This is one of the experimental plot. We have done almost 3 to 4 experiments at this particular location, as well as a few experiments in the farmers field, collected the eroded samples, sediments, as well as this is the difference between the actually lateritic soil, means low fertile soil. You can show the difference of absolute control without any fertilizer and fertilizer application. And this is 100%, 75% like that. So erosion has been quantified and validated with the model. This is next crop, Ashgard, their results. All this thing has been used for validating the model. And the next phase, we have gone into the district level. Means here I am showing only sample. We have taken in northern Kerala almost 6 districts. Just I am showing some 20 farmers in one district. So here the selection of farms was done based on these criteria. Main consideration was agroecological units. Then topography, lowland, midland, highland is the typical structure of Kerala. Then irrigated rainfed conditions, size groups, marginal, small, medium, and large. Then cropping system covering the major crops. Similarly, Kerala now it has been declared as an organic state. So that comparison also we have included. So these are all the farmers' plots we have selected, sampling, and interval was in once in 3 months to 4 months. If it's a perennial crop, we have gone for once in 6 months interval. So we'll give the soil health card at the time of initial recording, as well as we were continuously monitoring up to 4 years. And using that particular model, NUTMON, we have monitored that nutrient balance. So the peculiarity of NUTMON is that how the nutrient is flowing from one area to another area, we will be able to understand, so that we can easily address that issue and try to bring out strategies for implementation. And by combining all the outputs, whatever we have obtained from different results, earlier studies, as well as the recommendations from Kerala Agriculture University, as well as our CWIDM studies, we have developed this particular software. For this, copyright has also been issued, and now the Department of Agriculture is using this as a pilot project in some 3 districts. Here, actually, the farmer has to enter only their details. So background data like rainfall, the crop also he has to choose. The other soil related details, everything will be automatically generated from the background. So according to the requirement of his means selection of the crop, the recommendations will be generated and it will be given to the farmers. And with respect to carbon sequestration also, we had a project with the Department of Environment and Climate Change. So here what we attempted is, because as Sir was also initially pointing out about the carbon credit, actually we were the part of Niti Aayog expert panel for deriving the carbon credit framework, which is being carried out under a pilot project in Haryana, Gujarat, Punjab and all. So in that particular committee, they were suggesting to go for, if the temperature is increasing, what will happen? Similarly, if the rainfall pattern is changing, what will happen? So that kind of few experiments we have conducted at our institute. Suppose if the temperature increases by 1 degree or 2 degree, what will be the CO2 emissions? And to reduce the emissions or to manage or to improve the sequestration, what are all the strategies we can adopt? That we have monitored with the different field experiments. Some few I am sharing. And we measured the carbon dioxide flux using the carbon dioxide flux system, and we have an eddy flux tower also installed, so that all the air related or temperature related parameters, including evapotranspiration, everything is being accounted. And similarly, the management practices, suppose if you are going for mulching, what will happen? If you are going for drip irrigation, what will happen? So that kind of strategies also we have attempted and come out with a solution for that. Then coming to the rice, this is actually a World Bank supported project, mainly for going for the aerobic rice. What are all the techniques which is available? So few experiments have been conducted in the lateritic soil, not in the flooded lowland soils. So here we have tried to, because Kerala was actually almost 80% of the rice area has been reduced over the years. So they are trying to bring back the paddy cultivation even in the midlands and uplands. So we tried with aerobic rice in the uplands also. So this is the setup of the experimental field. And we have measured all those things. As I mentioned in the beginning, we have used different techniques like field measurements, photosynthetic data, transpiration, and using those data we have calibrated, and we have the spectroradiometer, which is a very costly equipment which collects the spectral signature of a crop, so that you can use it for the satellite based image predictions as well as the crop yield predictions. So which is coming very closer. This is what that right hand side of the image you can see. That is the top one is the satellite based image, whereas the bottom is the field level which we have measured. So with that we combined that together, and coupled with the crop modeling, we could able to predict the yield. And for the here the benefits we have attempted for Tamil Nadu districts also, Karur, Trichy and Pudukkottai. So later it can be aggregated to the district level or taluk level or village level also. We can come out with what may be the yield. For example, in-season yield forecast means during the stage of a crop itself we can predict, so that the water and nutrient management strategies can be attempted and improve the yield. And our accuracy was around 89%. Yield variation we have observed with the field level data, around 20% variation was there, but still it can be used for the field level knowledge. So this has also been published. And few of the studies, when we interacted with the farmers, as I mentioned, they were suggesting about the summer season issue, especially from January to May in Kerala. So we attempted a few drought assessment studies and how it is affecting the crop. So as I mentioned in the earlier project, we tried for the coffee, how it is affecting. One is April, 2007 is a wet year, whereas 2016 is a dry year. So how the difference is observed in the field, we have monitored, and the pest disease incidents, all those parameters have been recorded. And based on that, we have developed a decision support system, so that each fortnightly, means so once in 15 days it can generate the information or image of a particular region, so that we can understand how the status of the crop over to the historical data of last 15 years or 16 years, and then it can suggest the recommendations. So this is the software. It is a Northern Kerala Drought Information System, which we have developed for especially for the northern districts of Kerala, because most of our experiments were concentrating on the northern part of Kerala. And ultimately, based on whatever findings we have done, these are all the adaptation options with respect to the changing climatic era. These are all seems to be general, but most of the things we have tested and validated. And by considering the lack of time, I have not gone into the detail. But if someone of you are interested, I'll be happy to share those information also. And mainly, the projects were funded by these funding agencies. And this is just for the students. If someone is interested, 2 to 3 special issues are there, in which I am the guest editor, especially on scientific reports, climate change and food production. And in one agronomy, it is on deficit irrigation. And the third one is on soil nutrient dynamics. So if some of you are interested, kindly submit the papers also. So with this, I'm stopping here. Any clarifications or suggestions or doubts, I'll be open to. And we have a good bunch of team with the different as well as around 7 scientists in our group. So mostly it is done in a collaborative way with other institutes also. And for the other thing, we are open for collaboration also. If someone is interested, we'll be happy to associate. I was discussing with Prashant. Actually, it's a state science and technology institute, and president is Honorable CM. And we have around 8 institutes. This one is Center for Water Resource, and similarly we have Kerala Forest Research Institute. Like that, 8 institutes are there. One is Basic Sciences is also there. SRIPS we call it, Srinivasam Ramanuja Institute. Then Kerala School of Mathematics, Transportation Institute. Like that, we have some 8 institutes. You can just browse it. KSST, Kerala State Council for Science and Technology. In that, we are the one of the institute. And coming to our institute, we have a multidisciplinary scientists of around 35 people, including environmental sciences there. So we have an opening normally, currently, probably next 6 months or 1 year, the other scientist recruitment also may come. So keep check on our website. For scientist recruitment, PhD is the essential qualification. And currently 2 environmental scientists are there. And another one we are planning to recruit. But other than that, we will be having some 5 positions vacant, which will be advertised soon. Then we have a lot of projects running on. Almost on an average, we used to run around 40 to 60 projects in a year, but that will be a cyclic. So next year, like that, it will continue. So the project staff positions like JRF, SRF, RA will be every frequently. You can check the site. Definitely, even next week also there is an interview. And August 2nd there is a walk-in, especially for agriculture related. We have not specifically mentioned which subject. It's an Indian Council of Social Science Research supported project. Then other than that, we have internships for the students. For your MSc related work, you can come there and work for 3 months or 4 months. There will be 2 window we will be opening during January to March. 1 window will open, then October to December. So you can choose the guides or the scientists with whom you are interested to work based on their topics. And if you can directly contact them, or you can directly write to our director, so that every year we will be taking almost around 100 students. Means this 35 people will be guiding 2 to 3 students, because the expenditure will be met from the projects, so you don't need to spend, I think. Resources also we will be sparing. Then other than that, we are approved research center for PhD for many subjects, including environmental science, botany, chemistry, all those general subjects. Then engineering, especially civil engineering with special reference to water resources. Then biotechnology is there. Microbiology is also there. Then what else? Then we have postdoctoral fellowships, especially we call it as an Navakerala fellowship. It is exclusively for Keralites. But other than that, council as a fellowship in which national, like anyone can apply. So that also every year by January it will be. You can just check the site. Even for the PG as well as PhD also, we have few scholarships. Internships are available. So if you apply along with the recommendations from the department head as well as the chairman, you can submit the application, and maybe around 20 to 25 scholarships every year they are providing, including PhD as well as PG. The amount is very limited, but PhD you will get like a JRF fellowship, and postdoctoral fellowship is almost 1 lakh per month actually. So which is even higher than the Prime Minister's fellowship. But only thing there, the condition is the work should be related to Kerala. You have to work on Kerala specific aspects. So these are all in general. If you need any more information, please write to us. We are there to support. And other than these are all my means whatever we are working on related to that, I was suggesting, and many other people, especially with remote sensing GIS as well as environmental science, those people from Tamil Nadu are working there, especially in biodiversity boards, then pollution control board, all means temporary positions I'm saying. So frequently you can look for those options also. Definitely a lot of openings are there because biodiversity we have a panchayat wise, because Kerala has almost 976 panchayats. We have a biodiversity register for each panchayat, and that is being maintained by the project staff kind of thing. So each panchayat will have one position, so that will be coming frequently. On the Western Ghats, so environmental awareness is much higher, not much of industries. So even something to start, it is very difficult there. Awareness is much higher. So people themselves are more sensitized than the researchers. So even for our experiments conducting and all itself will be difficult. But once you, explain them, and if they understood, then the support will be very high. Otherwise, it will be very difficult. If they oppose, they will oppose it in a strong.
Thank you for your presentation. Sir, I have a doubt. By this DSS, can we overcome this hidden hunger in plants?
Definitely, that is why normally most of the decision support system, which I was working from my PhD part almost 20 years, like crop simulation models and all will not consider what you are talking about. But when you couple it with the nutrient balance, means what is available in the soil and how it is, what the cycle, how it is going. If you consider that circular pattern, then it is possible. That is why in our DSS we linked it with that, so that if the total pool is reducing, we will be able to understand. So at that particular point of time, if there is a possibility of hidden hunger, that can be understood. But recommendations we need to generate.
On what basis the crops are selected?
Mainly what we have worked is specific to that study area what we have selected, especially Kerala specific, and whereas Madhya Pradesh and Gujarat, the entire cropping pattern as well as crops were different, which I have not shown here. And paddy, since it's related to Tamil Nadu, that's why I have put. But Kerala as such, paddy area is drastically coming. Tamil Nadu, where we have attempted is, I have shown some 3-4 districts, Karur, Trichy, Erode, this western belt we have attempted. So it is fitting well into those regions also. But exactly the conditions will be differing from Kerala or Gujarat. Gujarat is a microcosm of Indian climate, because there you can find all the type of climates, whether it is humid, tropics, arid, semi-arid, all within one state itself we will get. That is why we have chosen Gujarat. And Bundelkhand, it was a fully dry region. Drought prone region, and Kerala it is entirely opposite, and it is a coastal wetland, means coastal region with the humid tropics. So then beyond the scope of the project, we attempted basically being from Tamil Nadu, I had an interest, and with support from some of the colleagues, we tried for the western belt also. So it is fitting very well to the condition. Mutually, like for the purpose of paper only, we will be working, since the framework is there. It can be easily applied to any area. If someone of you are interested, we are also open. Like, yeah, please.
The climatic conditions are changing. We are predicting the climatic condition by using some tools and modeling the crops. And how do you convince the farmer to change this from this crop to this crop by predicting future climatic conditions and modeling by using these tools? How do you convince and how do you suggest these crops are suitable for this region if the climatic conditions are about to change?
Question, I understood. It's a valid question. Like based on my experience so far, what I found is convincing the farmers in Tamil Nadu, or because we attempted in the southern Tamil Nadu also, Kanyakumari, that region. There and all, it is much more easier to convince when you compare to Kerala. But Kerala, what we observed is we have exclusively, if you look at that, two districts, Wayanad, Idukki, then Palakkad. These three districts are agriculturally important. And the farmers, like, not like the Tamil Nadu farmers, it's like what you call, farming is not the primary occupation. So it will be a secondary occupation. But even then, they will have a lot of awareness. So for example, pepper, it is totally wiped out from Wayanad. Mainly it is due to the climatic changes, or this extremes what we are talking is from 1980 to maybe 2020. Within this 30-40 years, the old people are used to tell. So now they are not going for pepper. Automatically they themselves have started changing. So when that particular situation, when the researchers like us or from the KVK scientists go, definitely they'll accept. So nowadays that changing is coming, and even many farmers are going for upland cultivation of paddy. So that is because of the efforts by researchers as well as the department officials. But it will be very difficult to convince, as you rightly pointed out. But once convinced means then the adoption will be easier. What we found is these three districts, it is much more easier, Palakkad, Wayanad and Idukki. Whereas other districts, we are finding it very hard because the other issues are also coming in between. So,
Paddy, we will see the differences in Kharif and Rabi season. We will see the tokens more in Rabi season paddy. Rabi season paddy, but while milling. So they go for parboiling in Rabi season paddy. Can you suggest any changes in the crop patterns or modeling for reduce these problems? Because farmers are facing more issues for by getting these tokens while milling.
Exactly, I understood the question, but exactly we have not worked on those areas. But the thing is that there in Kerala, what we found is exactly this Kharif, Rabi and say the summer season. That season itself is shifting actually. Normally, we used to get the rainfall, southwest monsoon starting from May end actually, or June first week. But last 30 years data shows that it is having a shift, and the extreme rainfall or the maximum rainfall we are getting after June only, July, August. So usually the farmers will go for Kharif season sowing during April, May, that time. Now they are shifting to June, July, like that. So there is a gap which is occurring based on the variability in the rainfall. Probably those kind of any reasons, if it works, we can try, but that brokenness or chaffiness and all, we have not worked. With respect to the chaffiness and all, we have worked, like the temperature, suppose if 6 degree increase is there, how many field grains will be there, those kind of thing. But milling part, we have not.
First, you introduce yourself, then you ask the question. I'm doing PhD first year about this. My question is that what are the basic conditions which are used for applying any crop modeling software based on climate change?
So as I listed that, few are very essential parameters. One is climatic data, but one thing we have to consider is what is the spatial resolution or what is the spatial extent you are using, whether it's for micro level or field level or regional level. So depending on that, that resolution may vary. but the requirement will be more or less same for whatever the levels you are using. First is climatic data, then soil or terrain data like slope, topography, all those things. Then crop related data, which is the crop, what type of management practices they are adopting. Then farmers' perception is what now in the IPCC AR6 it has come, shared socio-economic pathway. So economic conditions is also being considered in the current model, but earlier RCPs it is not considered. So all the parameters holistically is only considered. Only thing we have to check is that when downscaling or when you come to the smaller scale or micro scale, we need to validate it for our local conditions. And if you found with the historical data, if it is matching at least 80% accuracy is there, then you can very well believe that model for the future scenarios. Because we tried like that. So after 2015 to 2020, whatever that changes are observing, we could able to predict. But it may not predict the extreme events very accurately, but almost 80 to 90% accuracy you will get. It is based on the topology only. Like there it is very peculiar, Kerala compared to Tamil Nadu, because there we have lowland, midland and highland. Lowland what we call is less than 7.5 meters, 7.5 to 75 is midland, above 75 meters is highland. But it is a very short turn, within 120 kilometer width, we will reach that highest peak from zero mean sea level to 2,600 meters. So the runoff, erosion, everything will be very huge and retention time will be less. So it needs to be considered, otherwise models will not work. But Tamil Nadu, it is comparatively better since we have a almost plain topography. I would like to thank that.
That's okay, fine. Before PG coordinator proposing formal vote of thanks, I have few information to share. Dr. Surendran is there in our department. Now he is the principal scientist and head of the center. So he can make use of his availability at the Center for Land, Water and Management Research Group. And there are a lot of internship, as he rightly pointed out. You plan for internship. Okay? Then there will be scientist position also in the years to come. So you just send a mail and keep track any of the scientists, get the placement scientist position. And he is Dr. Surendran is very strong in publications, so you can get his guidance in writing papers. And he is also expert in models. So in our department, we have not used more of models in taking of research work. So you can make use of his expertise in developing models and involving that models for taking up your research work. And I've been discussing with Dr. Surendran for the past 6 months. We'll be initiating a MOU with their institute shortly. And two important domains I cannot ignore, environmental science and forest will be also included in the MOU. And the month of September and October will be signing MOU with the NParks Singapore. In that also we will include environmental science and forestry. This is for the information to the forum. Thank you. Now
Okay.
you can close it.
So in the beginning, as I mentioned, first of all, I would like to thank the entire team of environmental science, especially Professor and Madam Prashant and all the faculties for giving me an opportunity. As I mentioned, I am coming after a long time. So I am also feeling happy, and whatever now I have shown, the basics was from TNAU. So I can proudly say that I am a TNAUian. So based on that only, I can able to speak wherever many of the international projects or forum, the seed has come from TNAU. So you people also take it like that and try to excel in your career. And whatever support needed, we are free and free to support and always there. You are welcome, most welcome there to our institute.
Good afternoon to all. Today as we come to the end of the event, so on behalf of the Department of Environmental Sciences, I extend my heartfelt thanks to our Honorable Vice Chancellor Madam, Dean SPGS and Director DNRM for encouraging us to strive for excellence. And I express my deep sense of gratitude to the external examiner Dr. Surendran for the excellent review and the wonderful guest lecture. I thank our Professor and Head Madam for the continuous efforts for conducting this Viva as well as this guest lecture. And I also thank the Advisory Committee, Chairman members, Proctor, and the faculties and students of this department for participating and smooth functioning of this event. I once again congratulate Ms. Kirtana for securing doctorate, and thank you one and all.